to get this thing started. And that's the very deep assertion that y is equal to the square root of y times the square root of y. Okay? I love this. Because we're going to solve this radical equation or system of equations without doing any squaring. Okay, so this is certainly the truth. Y is equal to the square root of y times the square root of y. All right. Now you'll notice right here, this equation becomes 567 minus x quantity squared, but that's exactly what, right up here, you can write the square root of y equals to 567 minus x, just from this initial condition here. 567 minus x. Isn't that cool, folks? I love this. I think this is neat. All right, so square root of y is equal to 567 minus x. Y, this y right here can be written as root y, and there you have it. This is root y squared. Okay, so that's kind of cool because what it does, it gives us an immediate bounding condition. An immediate bounding condition. Notice that just based on what we have written down here, that this piece right here has to be less than 40. Now hopefully that's clear. Now this is probably kind of a crude upper bound. Probably you could put 39 squared here. I think you can. But anyway, this is an easy to compute upper bound. And so that means 567 minus x quantity squared has to be less than 40. Okay? Now what does this imply? Well, if you bring the 40 to the other side and bring x to the other side, you can rewrite this as x is greater than, what's 40 from 567? Is that 527? So we get x is greater than 527. Okay? So that's some help. Now, we don't have a lower bound really to speak of at this point, but let's see if we can work with this. Now, notice that we are positing that xy is a natural number solution. That's a positive integer, numbers like 1, 2, 3, 4, 5. So we're searching for a natural number ordered pair solution. So notice that y is a natural number by supposition, even though we're not saying we know there's a solution, but if there is, all of this is logical. Now, y being a natural number forces the square root of x to be a natural number because they have to sum to a natural number, which is what all this says right here, right? And so if the square root of x is a natural number, x has to be equal to some natural number squared. K is another natural number, okay? So we're looking for a natural number squared that is greater than 527, folks. And we could do a lot of computations if you want to, but I'm just going to go ahead and write down that that's 23. Okay, x is equal to 23 squared. And that's a fairly well-known square. That's equal to 529. Okay, equals 529, right? 20 times 23 is 460. 3 times 23 is 69. 460 and 69 is 529. So you get 529 right here. And again, y'all, that's just being familiar with your squares, your list of squares. This is kind of getting up there, but it's something that's within the realm of calculation. You know, so 529 is bigger than 527. Now let's go down and take a look. Now we still don't know if that's an answer or not, but we got to at least check it, right? Okay, and so right here, notice that if you substitute, what would this lead to? This would lead to 23 squared, or 529. Now, y'all, this is kind of fun right here because we now have some carte blanche to try to take advantage of the fact that this is a square root. All right, so we need this to add up to 537, right? So the choice would be 38 squared, since the square root of 38 squared is 38, right? So we would get 529 plus, and let me just write this down to the side here. Now that just works in the first equation. We'll have to check it in the second equation. So 529 plus the square root. You see what we're doing here, folks? We don't have to actually know what 38 squared is here. We just have to know the form. Okay, again, the square root of 38 squared is 38, and 38 and 529 is 537 that you see right here. Okay, so all we've shown is that would make this equation work. Okay, now if it turns out it doesn't work in this next equation, we would have to try the next highest value, I think. All right, but let's take a look here. So now we already know that the square root of 23 squared, right? The square root of 23 squared is going to be 23. All right, and we're asking a question in this. Okay, now we have to lose, okay? It's the square root of 38 squared, but now we're asking a question here. Okay, so does this equal to 1467? Question mark, okay? Does that equal to 1467? All right, well, 38 squared, it's underneath 1600, and if you multiply that out, I actually used a calculator to check this. This is equal to 1444. Okay, and that does add up to the 1467. Okay, so using this bounding, we got really close in a hurry. Now, y'all notice that 24 doesn't work. You can tell fairly quickly that 24 wouldn't work in the original equation, all right? Because that would be, you would need 576, right, which would be greater than that. I mean, 24 squared would be greater than 576. So that's a number greater than 527. So 529 is the one that does the trick. All right, and so what we see right here is the two solutions are 529 for your x coordinate. Okay, and 1444 for your y coordinate. That does the trick, folks. And the computations weren't too far beyond the pale, actually. And again, what I really like about this one is this very first part. I think is very cool because so many times people just start squaring away on this, then you have to worry about extraneous solutions. We didn't square anything. Y'all notice that we just replaced y with what it's equal to in a very elementary fashion. And right up here we had a statement that told us exactly what the square root of y is, right, when you subtract x from both sides. And then so you can just square the square root of y, but that is equal to 567 minus x per these initial conditions, okay? And then the bounding is very big, okay? This bounding right here, and these are crude bounds, but they still give you sort of a place to start, you know? Now, I'm not sure if it always works out where the nearest one always works, really, on these kind of problems. I'm not sure it worked out that way this time. But in any event, the bounding provided us with some vital information. And also, just one last thing, you could solve this problem without this even being here. You could just say, if there are natural number solutions, then yada, yada, yada. So you don't really have to stipulate this. I did it just for the sake of concreteness, I guess. But you don't really have to stipulate this. It's just, you could go, okay, let's check to see if there's any natural number solutions. Now, if there are any natural number solutions, then all of this logic here has to prevail, okay? So that's kind of the reasoning on this. So I guess it's a matter of style on what you want to include in your instructions. But anyway, this is the solution. X is equal to 529 and y is equal to 1444.